Hey everybody, Mrs. Horn here. Today our topic is water. What makes water so special? Why do all living things need and depend on water? And what properties of water make it unique for living things? So let's get started. I'm on page 7 in your biochemistry packet, and the most important thing that we need to come away from this lesson is that life exists because of these unique properties of water. There are 4 main properties of water that I want to talk about today. For each one, I have an explanation, and then I have a little picture that might help you visual learners make more sense of that. So one of the properties is cohesion. Cohesion is when water molecules are linked to each other by hydrogen bonds. So it's a water molecule linked with another water molecule, linked with another water molecule, and they're all combined through hydrogen bonds, and this helps to give water structure. Cohesion is when water bonds to water. It's important to understand also another term, adhesion. Adhesion is when water clings to other substances. We'll talk a lot about that when we do our plant unit later on. When water travels up the xylem vascular tissues of plants, it uses the process of adhesion. But adhesion is water sticking to things, and cohesion is water sticking to each other through those hydrogen bonds. And then I have a picture here of a bunch of water molecules all bonded together through hydrogen bonds. The next property is that water has a very high specific heat. So what does that mean? It means that it takes a lot of energy to heat or to cool the temperature of water. If the temperature of Lake Ontario is going to go up in the summer, it takes a lot of energy to be able to do that. I have a picture here just showing the ocean. I put it at about 68 degrees Fahrenheit, and then right on the coast is about 72, and then inland I put about 90. It looks like it's in the summer, looks like it's warming up, but it would take many, many warm days to get that ocean temperature, even to go up a half a degree. So having a high specific heat means it takes a lot to change the temperature of water, which is helpful in the winter when it gets really cold out. It takes a long time for it to freeze, which is very helpful for things that are living in the water. Something else that's going to help out in the winter is the fact that ice floats. When water becomes a solid, the water molecules expand, making it less dense, and it floats to the surface. So here's a picture of my pond, and the top level freezes. But below that top level, it's not going to freeze. My pond freezes, I don't know, 12, maybe 14 inches on really, really cold winters. But everything in the bottom is fine, so all the fish and the turtles and the frogs, they can still go way down to the bottom, and it's not going to freeze. Now, if water didn't float when it was frozen, it would be sinking at the bottom, and then where would these fish go? Life wouldn't be able to exist in bodies of water if ice sank. So water being less dense when it freezes is a really beneficial characteristic of water. And the last property of water that I want to talk about is water we like to call the universal solvent, which means a lot of things can dissolve in water. The picture I have here is a little beaker with water as the solvent, and I threw some sugar cubes in there. The sugar would be the solute. Now, if we were to let that sit, even without mixing it, that sugar is going to dissolve into the water. And then when we mix it a little bit more, it just kind of helps the process. You could add, when you make lemonade, when you use a lemonade mix and you add water to it, that is showing you this property of being a universal solvent. There are 2 vocab words that is important to understand. You probably remember from chemistry, hydrophilic and hydrophobic. Now, a molecule that's hydrophilic is something that likes to hang out with water. This is something that will dissolve in water It will hang out with water. It doesn't mind mixing with water, and a good example is sugar. Now, the opposite of that would be hydrophobic. Think of a phobia as something that you're afraid of. A molecule that's hydrophobic hates water, does not want to be with water, actually repels it. Oil is a great example. It does not like to mix with water. When you let your Italian dressing jar sit on the table for a while, you'll notice that it separates out from the, well, not water, but it separates out from the vinegar. It's the same, that would be the same visual example. The oil does not want to mix with water. Even when you try to mix it, when you put oil in water and you shake it up and you try to mix it, you'll notice there are just blobs of oil. They still do not dissolve in the water. Does not like it. Another thing to remember about hydrophobic molecules is that a hydrophobic molecule is a non-polar molecule. So oil is non-polar, and non-polar is not going to mix with a polar molecule. Water is polar, so that would make sense. And the very last thing I have here are aquatic insects, and they are really cool because a lot of them can walk right on water. And the reason why they can walk on water is because their legs are coated with a hydrophobic substance. So every time one of their legs touches the water, that substance does not want to mix with the water. That's a non-polar substance, which enables them to, one of the reasons why they can walk on the water. There's another reason. We haven't talked about surface tension, but that would be another reason. If their legs were coated with a hydrophilic substance instead, they would all sink, and it wouldn't really work out. We'd have a lot of sinking bugs. So that is everything we need to know about water, and I hope this helps.